The building code mandates that smoke detectors must be powered by 120 volts using 14/3 wire. This specification arises because 120 volts represents the standard voltage level within residential electrical systems. The 14/3 wire configuration incorporates three conductors, namely a hot conductor carrying 120 volts, a neutral conductor, and a ground conductor. Regarding the interpretation of burglar or fire panels, the notion that they cannot be utilized to supply power to smoke detectors, as suggested, is incorrect. National Fire Protection Association 72, which provides guidelines for alarm systems, sanctions the use of burglar or fire panels for powering smoke detectors. According to National Fire Protection Association 72, the panel must be specifically listed for the purpose of powering smoke detectors. Additionally, the smoke detectors themselves must be listed for compatibility and use with the panel. In practical applications, the alarm industry typically adheres to the stipulations outlined in National Fire Protection Association 72. This implies that burglar or fire panels are routinely employed to power smoke detectors in residential settings. The accurate interpretation of the building code dictates that smoke detectors must receive power from a 120-volt source through 14/3 wire. Nevertheless, this requirement can be satisfied through the implementation of a burglar or fire panel that is explicitly listed for the purpose of powering smoke detectors, in conjunction with smoke detectors that are listed for compatibility and utilization with the panel. The inspector's interpretation would not render the alarm industry obsolete, as the industry generally complies with the requirements of National Fire Protection Association 72 and installs burglar or fire panels capable of powering smoke detectors. Rather, it would necessitate the alarm industry to install a second smoke detector in each room, one powered by the burglar or fire panel and one powered by 120 volts with 14/3 wire. Now let's delve deeper into the technical aspects. Firstly, the 120 volts requirement is rooted in ensuring a reliable and consistent power supply to the smoke detectors. Unlike low-voltage systems, 120-volt systems have a low risk of voltage drops and power fluctuations that could compromise the functionality of the smoke detectors. Secondly, the 14/3 wire specification is critical for safety and functionality. The hot wire provides the power, the neutral wire completes the circuit, and the ground wire provides a path for fault current in case of a short circuit, thereby preventing electrical shock hazards. The National Fire Protection Association 72 standard is a comprehensive document that covers various aspects of fire alarm systems, including the installation, testing, and maintenance of smoke detectors. It addresses issues such as the placement of smoke detectors, the types of smoke detectors that are suitable for different environments, and the requirements for power supplies and wiring. When a burglar or fire panel is used to power smoke detectors, it must meet specific requirements to ensure that the smoke detectors will function properly even during a power outage. These requirements typically include having a backup battery that can provide power to the smoke detectors for a specified period, and having a system that monitors the power supply and alerts the occupants if there is a problem. The listing of the panel and the smoke detectors is a critical aspect of ensuring compliance with the Building Code and National Fire Protection Association 72. Listing means that the products have been tested by an independent laboratory and found to meet certain safety and performance standards. The listing mark provides assurance that the products are suitable for their intended purpose and have been properly evaluated. In practice, electrical inspectors often look for the listing mark when they inspect the installation of smoke detectors in alarm systems. If the products are not listed, the inspector may require them to be replaced with listed products. The debate often arises around whether a single smoke detector connected to a burglar or fire panel is sufficient, or whether a second 120-volt smoke detector is required in each room. The answer depends on the specific requirements of the local building code and the interpretation of the electrical inspector. In some jurisdictions, a single smoke detector connected to a burglar or fire panel may be acceptable, provided that the panel and the smoke detector meet the requirements of National Fire Protection Association 72 and are listed for their intended purpose. However, in other jurisdictions, the electrical inspector may interpret the building code as requiring a separate 120-volt smoke detector in each room, regardless of whether there is also a smoke detector connected to a burglar or fire panel. This interpretation is often based on the concern that the burglar or fire panel may not be as reliable as a dedicated 120-volt smoke detector, or that the occupants may not be as familiar with the operation of the burglar or fire panel as they are with the operation of a standard smoke detector. In such cases, the electrical inspector may require the installation of a second smoke detector to ensure that there is a reliable and familiar smoke detection system in each room. From an engineering perspective, the integration of smoke detectors with burglar or fire panels involves careful consideration of several factors. Firstly, the power supply to the smoke detectors must be reliable and consistent even during a power outage. This typically requires the use of a backup battery and a system that monitors the power supply and alerts the occupants if there is a problem. Secondly, the wiring of the smoke detectors must be properly installed and protected to prevent damage or interference. This typically involves using 14/3 wire and following the requirements of the National Electrical Code regarding the routing and protection of electrical wiring. Thirdly, the smoke detectors must be properly located and spaced to ensure that they will detect smoke quickly and reliably. This typically involves following the recommendations of National Fire Protection Association 72 regarding the placement of smoke detectors in different types of rooms and buildings. Fourthly, the smoke detectors must be properly tested and maintained to ensure that they are functioning correctly. This typically involves testing the smoke detectors regularly and replacing them if they are not working properly. It's also important to understand the different types of smoke detectors that are available and how they work. The two most common types of smoke detectors are ionization smoke detectors and photoelectric smoke detectors. Ionization smoke detectors use a small amount of radioactive material to ionize the air in a sensing chamber. When smoke enters the chamber, it disrupts the ionization process and triggers the alarm. Photoelectric smoke detectors use a beam of light and a light sensor. When smoke enters the chamber, it scatters the light and triggers the alarm. Ionization smoke detectors are generally more sensitive to fast-flaming fires, while photoelectric smoke detectors are generally more sensitive to slow smoldering fires. For this reason, it is often recommended to install both types of smoke detectors in a home to provide the best protection against all types of fires. Another important consideration is the interconnection of smoke detectors. Interconnected smoke detectors are wired together so that when one smoke detector detects smoke, all of the smoke detectors in the home will sound an alarm. This can be particularly important in larger homes or homes with multiple levels, where a fire may start in one area of the home and not be detected by smoke detectors in other areas. Interconnected smoke detectors can be wired together using a dedicated wire, or they can be interconnected wirelessly using radio frequency technology. In addition to smoke detectors, carbon monoxide detectors are also an important part of a home safety system. Carbon monoxide is a colorless and odorless gas that can be produced by fuel-burning appliances such as furnaces, stoves, and water heaters. Carbon monoxide can be deadly if inhaled in high concentrations. Carbon monoxide detectors are designed to detect the presence of carbon monoxide and sound an alarm to alert the occupants of the home. Carbon monoxide detectors should be installed in accordance with the manufacturer's instructions and local building codes. They should be located on each level of the home and near sleeping areas. They should be tested regularly and replaced if they are not working properly. The National Electrical Code, or National Electrical Code, provides comprehensive guidelines for the safe installation of electrical wiring and equipment. It covers a wide range of topics, including the types of wiring methods that are permitted, the requirements for grounding and bonding, and the requirements for overcurrent protection. The National Electrical Code is updated every 3 years to reflect changes in technology and best practices. Electrical inspectors use the National Electrical Code to ensure that electrical installations are safe and comply with the code. Electricians must be knowledgeable about the National Electrical Code and follow its requirements when installing electrical wiring and equipment. Several National Electrical Code articles are particularly relevant to the installation of smoke detectors. National Electrical Code Article 760 covers the installation of fire alarm systems, including smoke detectors. National Electrical Code Article 760 provides requirements for the wiring, power supplies, and grounding of fire alarm systems. National Electrical Code Article 760 also includes requirements for the interconnection of smoke detectors. National Electrical Code Article 725 covers the installation of Class 2 and Class 3 remote control, signaling, and power-limited circuits. Class 2 and Class 3 circuits are often used to power smoke detectors and other low-voltage devices. National Electrical Code Article 725 provides requirements for the wiring, overcurrent protection, and grounding of Class 2 and Class 3 circuits. National Electrical Code Article 300 covers general requirements for wiring methods and materials. National Electrical Code Article 300 includes requirements for the routing and support of electrical wiring, the protection of electrical wiring from physical damage, and the grounding and bonding of electrical equipment. National Electrical Code Article 310 covers requirements for conductors for general wiring. National Electrical Code Table 310.15b16 provides ampacity ratings for conductors based on their size, insulation type, and ambient temperature. This table is used to determine the appropriate size of conductors for smoke detector wiring. From a practical standpoint, when wiring smoke detectors, it is essential to follow the manufacturer's instructions and the requirements of the National Electrical Code. Here are some general guidelines. Firstly, use the correct type and size of wire. 14/3 wire is commonly used for smoke detector wiring, but the specific requirements may vary depending on the local building code and the manufacturer's instructions. Secondly, properly route and support the wiring. The wiring should be routed in a neat and orderly manner and should be supported at regular intervals. The wiring should be protected from physical damage. Thirdly, make sure connections are tight and secure. All electrical connections should be tight and secure to prevent loose connections and potential fire hazards. Fourthly, ground the system properly. The smoke detector system should be properly grounded to prevent electrical shock hazard. Fifthly, test the system after installation. After the smoke detector system is installed, it should be tested to ensure that it is functioning correctly. In addition to following the National Electrical Code and manufacturer's instructions, it is also important to use good workmanship practices. This includes using proper tools and techniques, taking care to avoid damaging the wiring, and ensuring that all connections are clean and tight. Good workmanship practices can help to ensure that the smoke detector system will function reliably for many years. The location is in New York. GPS coordinates 40.7514-73.9925. Remember that local amendments to the National Electrical Code may exist. Always consult the local authority having jurisdiction, or OJ, which would be the electrical inspector in this case, for any clarifications of the electrical code and its specific interpretation. This is especially important for new construction or renovation work. Understanding the code, its interpretations, and best practices are essential for safe and compliant electrical work. Always prioritize safety, accuracy, and continuous learning in the field of electrical work. This ensures both personal safety and the safety of those who will occupy the building. The alarm industry will not go out of business and generally complies with fire codes.